Okay, guys, this is just a quick video. I'm going to explain about the horizon and the actual descent of the horizon as you ascend, whether in an airplane or what you see from high altitude balloon footage. Yeah, the horizon will actually descend. It doesn't mean you're living on a convex ball, though. It has to do with the bending of the light and the angle of the trajectory of the light at that higher altitude. Here's another video from a pilot who's showing the horizon is actually lower. And so here's my diagram of the propagation of the light within the concave cellular Earth, emanating from the pyramid, extending to the sun, and then it's emanating on a curve like that and wrapping around and converging on the other side. So we have curvature here, okay? And let's go into Illustrator here. I have this set up for you. I'm gonna show you by taking these two periphery lines of the light, of the emanation of light extending from the sun, and I'm going to replicate that around the center. So let's zoom into the center point, and like that, copy it. Okay, now let's zoom back out. I'm just going to make 1 degree increments all the way around. Control D. Kind of like spirograph. One more. There. Okay. So let's say you're down here at the bottom and you're ascending up high. I'm zooming in really close now. Let's say one of these intersection points, let's say this one right here, we'll just put a little circle there. Let's say that's, I don't know, let's say 50 kilometers. And so you see the declination of the contour line, it's going down. And so that's going to be your range, your visibility range of the actual land of the Earth. And so it's going to be like going down right over here and then the other side it's going to go over here, and then it starts bending back up around. And so that's going to be your horizon at these intersections right over here. So obviously you're not looking, if you're looking just straight laterally across, you're just going to see, well, at 50 kilometers you're just going to see blackness. And so that's because the angle of the light is bending upward. And so your horizon is declining as you ascend. It all has to do with the actual angle and trajectory of the light. You know, if you're like way up here, let's say this is at, I don't know, let's just estimate that at space station height. You know, so obviously you're going to be able to see more Earth if we just follow that line. It's going to be kind of hard to follow it, but oh, there it is. You know, that's going to be the edge of your horizon over there, right there, and on the other side, this is going to be, and obviously it's going to get fuzzier too because you're going through the atmosphere, and so you're going to have a fuzzier horizon at that height. And so, you know, that's going to be your visibility range, your horizon at that height. Comprende? At this height right here. Make that a little thicker for you. All right. Zoom back out. So, yeah, your horizon is going to appear lower as you ascend. A long time ago, I made a video I was saying that the horizon is going to rise up to your eye level. Well, I guess I was mistaken. But this is really what's going to happen. You're living inside this cellular concave Earth with bending light. So after that point, your eye is leaving the ground. It doesn't see any Earth beyond that point. It creates the blind spot. So you know, after this point right here, it's just going to bend up back around like that. And you're going to begin to see blackness. It's going to bend up around toward the center. I have it going toward the sun. But it feeds to the center. It actually hits the celestial sphere perpendicularly. So it's always going to go toward the center. Okay? Thanks for watching.